Hello everyone. The title of our work is Effects of Machining Methods on Uniaxial Tension Properties of a 75 micron thick 3004L stainless steel foil. The ultra-thin stainless steel foil is needed in industry. While the intrinsic size effects are known, the interaction between machining-induced edge signatures and gauge weights remains unquantified. The objective of our work is to distinguish between the defect driving and necking driving failure modes using full-field DIC. Here's the material and its microstructure. And we prepared the samples by 5 different methods and tested under uniaxial tension and use DIC to quantify the strain. An image-based processing technique is used to quantify the edge roughness. And based on the global mechanical response, the strains are quite consistent. However, high scatter in uniform and fraction elongation are found. And based on the digital image correlation technique, we found that the laser cutting and photo etching specimens are failed due to intrinsic failure, while the other 3 groups samples are failed due to the defect. And the width-dependent size effects are observed, that the ductility is generally increased with gauge widths for these 4 groups, while the waterjet cut specimens is an exception. The reason here is the wider specimens have a smaller machine-affected zone to cross-section ratio, suppressing the localized necking. The conclusion here is the strength is bulk dominant, while the ductility is process dominated. In this way, the laser cut and photo etched specimens are ideal for measuring the intrinsic properties. Thank you for your listening.